Hello, this is Nikki Jackson, one of the adjunct instructors for Concorde Career College, the winter term 2021 for Math 1320 College Algebra. Right now what we're going to cover are a few examples that would be taken from Module 2 homework. Now please note that we tried to do a virtual live version of this earlier today. Unfortunately, technology didn't work with us. So hopefully students and some of the instructors will be able to access this in Canvas once this recording has been posted. So, here's the first example provided for you. You may notice that this is an equation, and you know this is an equation because you see the equal signs right here. So most of you may remember how to solve an equation from middle school or high school or just basic math terms, but let's break this all the way down. One of the first things that we want to do is identify what the variable is. In this case, the variable is whatever the letter is. In this particular example, the letter is X. So for step one, we want to identify what our like terms are. So in this case, notice how I circled in green the -8, and then right here I did the -10. Negative and minus are one and the same, so I will be interchanging those words. But both of them are negative at this time, and they also do not have variable, hence they're considered constant. Well, notice how the -8 is over here by itself. So what we're going to do now is try to isolate the variable by combining our like terms. So we can't do anything with this 8 because it's already by itself, but we can balance the equation by adding 10 to both sides. So right here it cancels out. Then right here you see -8 plus 10. Next step, we're going to isolate the variable. So notice now that you have -8 plus 10 gives you 2. Bring down the 2x. When you see it attached like this, that automatically means that it's going to be multiplication. And because we're balancing the equation, one of the ways that you balance the equation is doing the opposite operation. So the opposite of multiplication is going to be division. So notice how I rewrote it. So if I do it on one side, I do it on the other. So now we get to solve for x. These two 2's cancel out. And this right here, you actually do the operation. So 2 divided by 2 gives you 1. These two, as previously stated, cancel each other out. Hence, your final answer is 1 equals x. Another example pertaining to an equation is this right here. So please feel free to stop and rewind this video at any given time. Notice how I'm doing it pre-recorded. So again, rewind, fast forward, whatever you feel most comfortable with, but let me make note that I will be flipping the page quite a bit because I'm actually writing the problems out. Your next example is dealing with an equation. Notice how I said equation because I see the equal sign. Once again, we're going to combine our like terms. But before we do that, let's identify what they are. So notice how I circled the ones with the variable x in it, and I underlined the numbers without an x. Now we combine the like terms. Because 9 is bigger than the 5, I want to try to keep those, like the bigger numbers together. You can easily subtract 9 from both sides, but as I just said, I like big numbers, so I'm going to keep it like that. So the opposite of a minus is a plus, so add 5 to both sides. This 5 cancels this other 5 out. Now we have 3x equals 3x plus 14. We still have to combine the like terms because we still have 3 x's on opposite sides of the equal sign. Notice how this 3x is completely isolated, meaning there's nothing going on with it. You just see 3x. You don't see an addition or subtraction, just 3x. So this is the one that we're choosing to subtract. Now why am I subtracting? It is automatically assumed that this is going to be positive. The opposite of positive is a negative. Hence, we're doing this part right here. Well, check it out. If we do 3x minus 3x, that's going to give you 0. Now the only thing I did now was bring down that 14. But hold up, wait a minute. 0 doesn't equal 14 at all. So that means that this is going to be an empty set. So when you type your answer in, literally type in the word empty. That should be an option for you because it's multiple choice. So far, we're doing equations with variables on two sides of the equal sign. Here goes your next one. So take a moment to actually review that and look at it. Now the examples that I'm doing are going to look very similar to the ones that you see on your homework. The only difference are going to be like the actual numbers themselves for some of the problems. So for this one, first thing we're going to do is do the distributive property. By definition, that means whatever is on the outside of the parentheses, you're going to multiply by each term on the inside. So 6 times x, that's going to give you 6x, and then 6 times 3 gives you 18. Notice how I brought down the 18, and I also brought down the minus 48. Now we're going to identify our like terms and then combine them. So notice how I circled the negative 18 and the negative 48. Those are not just like terms because both of them are negative. They're also like terms because both of them do not have a variable. Hence, they're called constants. The negative 48 is already isolated. So what we're going to do is add 18 to both sides of the equation. Hence, we're going to balance the equation. These 18 cancel each other out. So you can just easily cross them out if you want to. So I'm going to erase that. So now we have 6x equals negative 30. And the reason why it's negative 30, using your calculator, do negative 48 plus 18, that's going to give you the negative 30. Now here's a quick rhyme whenever you get stuck with integers. Like signs you know you add, unlike signs subtract. Take the sign of the greater number, then you'll be exact. So once again, like signs you know you add, unlike signs subtract. Take the sign of the greater number, then you'll be exact. So since these two are unlike signs, we're going to subtract, hence the 30. 48 is bigger in value than 18 in regards to absolute value. Hence, it's going to take the same sign as the 48. Moving on with solving the equation. We're going to isolate the variable by dividing both sides by 6, because that's what's attached to the x. That is a positive 6. So when you divide a negative by a positive, the answer is still going to be negative. So your overall answer is going to be x equals negative 5. Here's another example pertaining to the distributive property. So if you're following along with me by writing them down yourselves, take a moment to do this because this is a little longer. You know that you're doing the distributive property because you see the parentheses. So once again, whatever is on the outside of the parentheses, multiply by each term on the inside. So hence, we have the distributive property. We have negative 2 times 5x, which gives us negative 10x. Negative 2 times 6 gives us negative 12. So that's what we have right here. And then we have negative 5 times 4x gives us negative 28. Then negative 5 times 1 gives us negative 5. A quick reminder, hopefully you can see the red right here. When you multiply a negative times a negative, that gives you a positive. When you multiply a positive times a positive, it's also positive. So notice how these are like terms. But when they are unlike terms, a negative times a positive gives you negative, and a positive times a negative gives you negatives. So like terms give you positive, unlike terms give you negatives. This only applies with multiplication and division. Still trying to solve for the equation now. We're going to identify and then combine like terms. Notice how I circled the negative 10x and negative 20x because both of those have the variables, and I underline my constants with negative 12 and negative 5. Well, once again, we're going to combine our like terms by doing the opposite operation. So the opposite of subtraction is going to be addition. You may recall earlier that I stated that I like to keep the numbers bigger, meaning that I also like to keep them positive. So in this case, negative 5 is bigger than negative 12 because this one is closer to 0. So we're going to add 12 to both sides. Side note, You can add 5 to both sides, but your answer is going to be negative. Regardless, your overall answer is still going to be the same thing. But right here, I chose to keep it positive, so these cancel out. Now I have negative 10x equals negative 20x minus 5. I'm sorry, plus 12, plus 7. So negative 5 plus 12 gives you the positive 7, so these two cancel. I still have to combine my like terms. Since the negative 10x is already isolated, we're going to add 20 to both sides of the equation. So voila. Bring down your 7. Your next step is going to isolate the variable. So that means we're going to divide both sides by 10. So you're going to write what you see. Notice how you see 7 over 10, because remember, a fraction is just like division. These two cancel each other out, so you no longer need those. Bring down the x. And keep it as a fraction. Do not enter a decimal. So be mindful of that and pay close attention when it's asking you to enter the answer either as a whole number, integer, or fraction. So do not enter this as a decimal. Now, if you get confused on how to convert your fractions into decimals or interchange them with one another, hopefully you're able to use the TI-83. If not, please feel free to use MathWave. But be mindful, MathWave is not going to be able to do all your problems for you. Our next example is pertaining to a word problem. So give me just a moment to actually find that example. Reading is fundamental. So you're going to have to read each problem very, very carefully to know exactly what's going on. So my apologies. It is all wrinkled and everything, but hopefully you can look past it and look at the actual problem. So let me zoom in so you can see it a little bit better. I zoomed in just a little bit too much. Alright, there we go. So once again, apology for the wrinkles. The problem states that Angelo is paid double time for each hour he works for over 40 hours in a week. Last week he worked 46 hours and earned $572. What is his normal hourly rate? So we're going to say the rate is going to be represented by the variable R. So if we look at this carefully, Angelo is paid double time for each hour he works over 40 hours. So I'm going to say 40R is going to be his regular rate. But then it says it pays double for whatever he does the hours over the 40 hours. So check this out. So I have my regular rate. So my regular weekly rate was the 40R plus double your rate for however many hours over that he was working, and then you had your total for $572. So once again, your regular rate is going to be the 40R. Then it's going to double the rate, hence the 2, for however many hours we're over. So when it's your turn to do this problem, this number right here is going to change, and this number right here is going to change. So what I did first was simplify it by using distributive property. So I brought down my 4R. 46 was how many hours he worked that week. So then I subtracted 46 minus 40. Brought my 576 down. When I subtract, I know he had 6 hours overtime. So now I did twice my 6 hours. Bring down my R. So 2 times 6 is 12. Bring down your 40R. Remember, that's your weekly rate. Now we've already doubled the rate, and we have a weekly rate. Because the rates are what are in common, we combine our like terms, which gave us 52. Now divide everything by whatever your total is, and you should have gotten 11. So don't forget, when it's your turn to do this problem, read it carefully so you know exactly how many hours total he did that week, which is going to be your X, and then the total amount, which is whatever he owed or made that week. So hopefully that brought some clarity. Another one that you're going to have to pay close attention to are your fractions. Now I'm going to be honest, ladies, gents, individuals, I do not like fractions. I can't stand fractions. The only time I deal with fractions is when I'm eating a pizza. And I still don't like them then because the pizza's already pre-cut. But anyway, make a long story short. Fractions are the same thing as division. Notice how the 3/4 is attached to the x, so that automatically means multiplication. Here's a fun fact. That's also why they usually use the variable x, because it's usually multiplication. So back to this fraction. Fractions are divisions. So for example, in this case, instead of having 3 fraction bar 4, you can actually say 3 divided by 4. So dividing fractions require a reciprocal, because fractions themselves are, division. What I mean by reciprocal is mean flip it. So now I'm going to flip it. So if I do it on one side of the equation, I have to do it on the other side of the equation. So I flip the 4/3, meaning 3/4 to 4/3. These 4's going to cancel out. These 3's are going to cancel out. But now I'm going to do 9 times 4, which gives us 36, and leave the 3 alone. Now another way of saying that is just multiply your whole number by your fraction or the numerator of the fraction. Or another way of writing that is going to be 9/1 times 4/3, which still gives you the 36/3. So that's another way of doing that. Still not quite done yet. Even though some of our answers can be given to you in fraction form, we're going to simplify this. And the way that we simplify is simply by dividing 36 by 3. And our answer is 12. Moving on to yet another fraction. Like, oh my goodness, why are we doing all this? Well, I'm going to show you what you got to do first. Once I erase this digitally, here we go.